Hello children, today we are going to learn about the introduction of chapter 3 current electricity. In the first two chapters, we were studying about charges that were at rest. That is, in the movement illada charges patti namma padichittundo with the branch of physics that deals with static charges is called electrostatics. Static charges, electrostatics. So now in this, we are going to study about electric charges in motion. So study of electric charges in motion. So this branch is called current electricity. First நம்ம electric current என்னன்னு பார்க்கலாம். So now let us see, take two bodies, body A and body B. இது ரெண்டுலயுமே there are different potential. Okay. So now we have a conducting wire or a conducting wire. We are connecting these two bodies A and B with the help of this conducting wire. What will happen? Charges will start flowing from the body with the higher potential to the body with lower potential. So, இப்ப இதுல higher potential இருக்குன்னு வைங்களா, இது lesser இருந்துச்சுன்னா from A to B charges will start flowing. So, the charges will continue to flow until the potential of V of A is equal to V of B வரைக்கும். அது வரைக்கும் flow ஆகும். Okay, so there is a flow of electric charges from the higher potential to the lower potential. So this flow of electric charges will constitute electric current. So flow of electric charges. This constitutes electric current. So now how do we define current? Flow, in simple terms, whatever you have learned in grade 10. Current is the flow of electric charges through a conductor. Flow of electric current. அதுக்கு நீங்க படிச்சிருப்பீங்க. I is equal to Q upon T. So now let us say take a conductor. Okay. We will draw a conductor. So in a conductor, you know that there are so many free charges. These charges will keep on having a small movement at room temperature. They keep on drifting. And they collide each other. After collision, they again move in random direction. So that at a particular point, when there is no electric field, the number of electrons traveling in the forward direction will be equal to the number of electrons traveling in the reverse direction. Okay. So the net movement of electrons will be equal to 0. But now, when there is an electric field, what happens? The electrons will be moving from the negative terminal towards the positive terminal. They will be ordered in a way that if this is positive and this is negative, they will be ordered in a way that they move towards the positive terminal away from the negative terminal. Correct? As a result, there is a current flow. Now, in this sense, if we define electric current in a conductor across an area means this area held perpendicular to the direction of flow of charge. So this is the direction of flow of charge. We are taking an area perpendicular to the direction of flow of charge. It's equal to the amount of charges are flowing across this area per unit time. Okay. So that is I is equal to limit. We are taking a small time. So limit del t tends to 0. Del q by del t. That can also be written as dq by dt. This is the concept of current electricity, or how current flows in a circuit. Again, what is the SI unit of electric current? Ampere. So 1 ampere is a large unit. So we go for smaller units like milliampere, microampere. 1 milliampere is equal to 10 power minus 3 ampere. 1 microampere is equal to 10 power minus 6 ampere. Now, this electric current, you will be observing in many situations. Take a battery. What will be the nature of current flowing from a battery? Is it varying always, or it is stable? It is steady, or is it steady, or is it varying? The current flow is always steady, right? Such type of current is called steady current. The output current is always constant, then we call it steady current. So example, battery, hearing aid, transistor radio, all these will be examples of steady current. You all know lightning, right? Okay. What is lightning? How is lightning formed? Lightning is the flow of electric charge between two clouds, or between a cloud and the earth, right? So what is the amount of charges that is transferred when lightning occurs? A very high amount of charge is transferred when there is lightning. So such type of current is called transient current. That is a large amount of charges flowing for a very short duration, which is known as transient current. So steady current I is equal to Q upon T, and transient current I is equal to del Q upon dQ upon dt. Okay. So this is all about electric current. And is current a scalar or a vector? Electric current has both magnitude and direction, but it is a scalar quantity because you cannot perform any vector addition in electric current. Okay, you can only add it basically. Algebraic addition, algebraic addition can be done. And there are so many laws and rules to solve to find out current in a particular network also. But you cannot do any vector addition here. So electric current is a scalar quantity. I is a scalar quantity. I is used to represent current. Okay. So now this is all about electric current. Let's see the typed format of this. So the definitions are given. Please pause the video and take notes and continue with the next part. So here you can see the diagram. In this diagram, you can see the electrons are moving from the negative terminal to the positive terminal. Okay. And current is defined to flow from positive towards negative in this direction. That is why we say that this type of current flow is called conventional current. And the direction of electrons are opposite to the direction of flow of current. So if electric current in conductors. So in conductors, as we discussed earlier, when you apply electric field, electric charges start moving, which will constitute electric current. So if you take a solid conductor, this movement is due to the negatively charged electrons. But on the other hand, if electrolytic solutions current is carried by the motion of positive and negative ions. Dissociation principle. One electrode and the inner electrode, the ions start moving. Okay, that will constitute current. So this all we have discussed earlier. When there is no electric field, what did we see? The average velocity is 0 because the number of electrons moving in the forward direction will be equal to the number of electrons moving in the reverse direction. So average velocity is 0. This is when the E not equal to 0, so that there is significant movement of electrons which will constitute the current flow. Okay. So with this understanding, we will move on to few sample questions. 10 power 20 electrons, each having charge of 1.6 into 10 power minus 19 coulomb, pass from a point A towards another point B in 0.1 second. So number of electrons is given. 10 power 20, charge of each electron is given. 1.6 into 10 power minus 19 coulomb. Time is given 0.1 second. You have to calculate the current in ampere. And you have to find its direction. You know that I is equal to Q by T. And Q is equal to NE. NE by T. Now substitute the values. N is 10 power 20. 1.6 into 10 power minus 19 divided by 0.1. Correct? Okay. So now 10 power 20 powers minus 19 into 1.6 by 0.1. So 0.2 common you can just remove it because there is one decimal place after the point in the numerator and the denominator. Now this becomes 20 minus 19, 10 power 1 into 1.6 divided by 0.1 is 16. So 16 into 10 is 160 ampere. This is the current. Chariya? Calculate the current in ampere and give its direction. So electrons move. It passes from point A towards another point B. So we have already discussed current flows in the direction opposite to the flow of electrons. So it will be, direction of current will be current is from B to A. Very good. Okay. So this is how we do this sum. Okay. Next question. How many electrons pass through a lamp in 1 minute if the current is 300 milliamps? Here you are asked to find out N. Same formula. I is equal to Q by T. That is equal to NE by T. So now N will be equal to IT by E is equal to N. So you have to find out this. Here I is equal to 300 milliamp. Time is equal to 1 minute. That is equal to 60 seconds. E we already know. That is equal to 1.6 into 10 power minus 19 coulomb. So here substitute what you will get. 300 into 10 power minus 3 into 60 divided by 1.6 into 10 power minus 19. Okay. So now when you solve it, you will get it as 3 into 6 into the zeros, 3 zeros, right? I'm making it as 10 power 3 so that I can cancel the minus 3 divided by 1.6 into 10 power minus 19 is equal to N. Now 10 power 3 and minus 3 will become 0. So 18 divided by 1.6 into 10 power plus 19 will be equal to N. So if you solve this, divide this and find out, you will get it as 1.125 into 10 to the power 20 is equal to your number of electrons. Okay, please pause the video and do the calculation and then we will continue. 18 divided by 1.6 will be 11.25. I hope you have done the calculation and checked. 18 divided by 1.6 is equal to 11.25 into 10 power 19. Okay, so now to write it in scientific notation, I have moved to 1 point. So 1.125 into 10 to the power 20 will be the number of electrons. In a hydrogen atom, the electron moves in an orbit of radius 5 into 10 power minus 11 meter with a speed 2.2 into 10 power 6 meter per second. Calculate the equivalent current. So in this case, if an electron is revolving in a circle of radius r with speed v, The period of revolution of the electron is given by T. Time period T is given by 2 pi r by V. This is what you learned in grade 11. And frequency nu. Okay. Frequency nu is equal to 1 by T. That is V by 2 pi r. Now current at any point of the orbit will be given as I is equal to charge flowing in one revolution into number of revolution. So number of revolutions can be taken from frequency nu. So I is equal to E nu. Okay. So with this understanding, you have to solve the sum. So you know that V is given, like orbital radius R is 5 into 10 power minus 11 meter. V is 2.2 into 10 to the power 6 meter per second. Okay. Now, E value also you know, 1.6 into 10 power minus 19 coulomb. Now you find out T, 2 pi r by V. So you will be getting 2 into 3.14 into 5 into 10 power minus 11 divided by 2.2 into 10 power 6. Okay. And frequency will be the reciprocal of this frequency. Nu will be equal to 1 by T. So that will be the reciprocal. So you can take the reciprocal and itself solve. Rather than solving this and taking 1 by, take the reciprocal directly and you can solve. So that you get 2.2 into 10 power 6 divided by 2 into 3.14, 2 pi r, right? 5 into 10 power minus 11. Now, if you see here, see there is 2.2, right? If I substitute instead of pi, if I substitute 22 by 7, I can cancel this. So, this 3.14 you can discard and you can take it as 22 by 7. You have to understand the case and you have to use what value you are substituting. So, when I do 22 by 7, 22 will be here, 7 will go to my numerator. Correct? So, this I can cancel. So, you will get it as 7 into 10 power 15. So, this is frequency is 1 by T, right? So, per second. This will be 10. This will be 1. Okay. And here there is 7. And 2 into like 5 is again 10. So you will get 7 into 10 power 6 divided by 2 into 5, 10. 10 into 10, 100, right? 100 into 10 power minus 11. So that is 10 power minus 9. When it goes up, it becomes 10 power plus 15. Okay. So that is how you get this answer. So now you know the frequency. So now current at any point in this orbit, I is equal to E nu. So now E is 1.6 into 10 power minus 19 into the 7 into 10 power plus 15. So now multiply 1.6 and 7. So I can simplify 10 power minus 19 and plus 15. You get minus 4. Again, when you multiply this, you will get it something like 11 points. So now to write it in scientific notation, I'll write it 1.12 into 10 power minus 3. Just multiply this and convert it to scientific notation. Okay, this is how you solve the sums related to current. I hope you have understood. If you have any doubt, please let us know in the comment section. We'll be happy to help you. Thank you.